Well, my name is Dr. E, and for today we're going to be working on word problems involving numerical relationships, specifically direct variation. In mathematics, it's important that we are recognizing patterns. So patterns involving our data sets, and that is what we're going to be working on today. So the patterns that we are seeing, it's not limited to the formula that we are using in geometry or in trigonometry, but in a relationship, when we have two quantitative data, there's also a relationship that we need to look for, and that's what we're going to be working on in our lesson for today, which is variation problems involving quantitative data or numerical values. And in this particular formula or pattern or relationship, we're going to be specifically talking about direct variation, also called as direct proportion. And in this particular relationship, we have x and y as our two variables, specifically quantitative variables, wherein in this equation, k, or our constant of variation, cannot be equal to 0. So this is the formula that we're going to be using for the problem today. Y equal to kx, where y and x are the variable for our input and output, and the unique numerical value that will dictate how much it will increase or how much our output will decrease will be our value of k, or the constant of variation. So in some word problems, whenever we are looking at y is equal to kx, one language or words or phrase that we normally associate this with is y varies directly with x. So this is the type of language that we're going to be using when we are talking about specific relationship like direct variation in mathematics. So that means if we have z is equal to kt, we can say that k varies directly with t, which is, again, the clue or the verbal cue that you need to look for or watch out for when you're working with problems similar to this one. And remember that k is extremely important in this particular relationship because this k is the constant of variation or the pattern that we're going to be looking for, or numerical value or constant that we're looking for, that will dictate the strength of the relationship numerically. So let's say we're talking about real life examples. So since we're talking about word problems, we're talking about mathematics or using mathematics to solve problems in verbal form. So some relationship that is considered to be an example of direct variation is the number of cupcakes you can bake varies directly with the amount of flour you have. So that means the more flour you have, the more cupcakes that you can produce, and the less flour you have, the less number of cupcakes you will produce. And notice that your independent variable or the independent or input here is your amount of flour, and your output is the number of cupcakes you're producing. So if one is increasing, your output is also increasing. And when your input is decreasing, your output is also decreasing. And this is the clue that you are going to look for when you're working with direct variation. That's why it's called direct variation, because there is a direct influence or impact to our output based on our input. So another example of this example or relationship is the grade you earn in your math class varies directly with the scores you get in your quizzes. And the number of hours you work in a day varies directly with how much you will earn in a month. So these three examples are relationships or examples of relationship that involve direct variation, because if your input is increasing, your output is also decreasing. And if your input is decreasing, your output is also decreasing. I hope I did not confuse myself with that particular comparison. However, let's start with our problem, which is, in this case, we know that we're going to be working with the formula y is equal to kx, because in this problem, it says here if y varies directly as x and y is equal to 48 when x is equal to 6, then find y when x is equal to 15. So there's so many words in this problem that you need to process, but the very first statement is giving you clue on what you're supposed to be doing. And it says here y varies directly as x, which means we're going to be using the formula y is equal to kx to answer this problem. We also need to find a specific value of y when x is equal to 15 based on our equation in this problem. So we're going to establish that equation from our first statement, which is y varies directly as x and y is equal to 48 when x is equal to 6. So to do that, since we're going to use the formula y is equal to kx, and the reason why we're using it, it says there y varies directly as x. So that is our verbal clue that we're going to be using this specific formula for this type of relationship. And we are given the value of x, which is 6, and the value of y, which is 48. So all we need to do is to plug it in to our equation y is equal to kx. So that means y is equal to 48 and x is equal to 6. And now all we need to do is to use our algebra skill to find the value of k by dividing both sides by 6 so that k is by itself. And we know that 48 divided by 6 is equal to 8. So k is equal to 8. So now that we have our constant variation by using the formula y is equal to kx, where y is 48 and x is equal to 6, all we need to do is to plug it into the formula, solve for k, and make sure that you know your multiplication table so that you would know that k is equal to 8 because 48 divided by 6 is equal to 8. But wait, there's more because we need to find the specific value of y when x is equal to 15 based on this problem. So what we're going to do is we're going to process our equation once again, and this time our equation is now going to be, so from y equal to kx, our new equation will be y equal to 8 times x because this is the specific function that we produced based on our word problem. And to find the value of y when x is equal to 15, all you need to do is to replace 15 with x and you will find the specific value of y in this particular problem. And 8 times 15 is what you're looking for in this particular problem. So when you use your formula and you write your direct variation formula, by multiplying 8 and 15, we'll be able to produce 120, and that is the specific value of y that we're looking for when x is equal to 15 based on this numerical relationship. So again, the clue here is directly or varies directly as our indicator that we're going to be using y is equal to kx for this particular problem. So let's go ahead and answer problem number 2. Problem number 2, it says here, if y varies directly as x, find the constant of variation k and the direct variation equation given that y is equal to 5 when x is equal to 30. So again, there's so many words right here, which is a little bit confusing for beginners, but if you know what to look for and you know how to organize your work, this is actually really simple because here we already know that we're going to be using y is equal to kx because from the first statement, it says y varies directly as x. All we need to do now is to, 1, look at the first statement and see which value we're looking for. And here we're looking for the constant of variation, k. So we know that we're going to find the constant variation k. And then after that, we need to write the direct variation equation. So just like what we did on our previous example, we're going to use the values given to us and start organizing our work. We know that we're going to be using y is equal to kx as our formula because it says y varies directly as x. We need to find the constant of variation k, so this is what we're looking for. And we know that y is equal to 5 and x is equal to 30. So y is equal to 5 equal to k times 30. And this is now our formula specific to our word problem. All we need to do is to find k by isolating k, and now we have 5 over 30, and we know that 5 over 30 can still be simplified because 30 is 5 times 6, and we can cancel it out, which is equal to 1 over 6. So this is the value of k that we are looking for, and this is the first part of our answer because now we found the constant of variation. All we need to do is to find the direct variation equation. And how are we going to find the direct variation equation? Of course, we're going to be using the same formula, but this time we'll just replace k with 1 over 6 because that is the constant of variation specific to this relationship. So recap, we first found k by plugging in the value of x and y and by manipulating our formula according to this problem and using our basic algebra skill of isolating k in the equation, we're able to produce k is equal to 5 over 30, and we know that we can simplify 5 over 30 and it will equal to 1 over 6. And now that we have our k, which is 1 over 6, we're going to be writing out the same formula y is equal to kx, but this time replace k with 1 over 6. So the direct variation equation is simply y equals 1 over 6x. And that is how we answer these two problems. It can be overwhelming at the beginning, but if we are just going to work on each phrases in the word problem, it's actually really simple. So let's go ahead and answer another type of this relationship, and this time our relationship is in table form. So we need to write the direct variation equation of the form y is equal to kx that satisfies the ordered pairs in the table below. And if you will notice, just like what I mentioned on the first slide, direct variation relationship, it's when your input and your output is directly affecting each other. So if your input is increasing, your output should also be increasing. So that is what's happening in our table of values. 2 is to 6, 9 is to 27, 1.5 is to 4.5, and negative 1 is to negative 3. So let's see how we're going to approach this problem. First, let's use the formula y is equal to kx because it says there that the relationship of this ordered pairs is a direct variation. All you need to do now is to choose which point to work on for this particular problem. And in this case, I will just use the first set of ordered pair, which is 2, 6. So our input is 2 and our output is 6. So we are going to be using this so we can find the constant variation k in our equation. So by replacing the value of x and y, so x is equal to 2 and y is equal to 6, we'll be able to find our constant variation k because 6 equal to k over 2, we simply divide both sides by 2 and we'll be able to produce k which is equal to 3. And now that we have our k, which is our constant variation, we'll be able to write the equation of this relationship from y is equal to kx to y equals 3x as our equation for the direct variation relationship for this table of values. So different types of problems, but same approach as long as you're understanding to find the clue is to find the word direct variation so that we know that we can apply the general formula for today, which is y is equal to kx. So let's go ahead and answer the last problem of the day, which is this time, it's not in word form. Well, in word form at the beginning, explaining what the graph is. Now, that's what we're going to be working on. A graph of the relationship of your x and y, and we're seeing a linear equation, which is the blue line. And we know that if we have a linear equation or a diagonal line, this resembles a specific formula in algebra that most of you are familiar with, and we're going to be working on that so that we can complete our work. So we know that we're looking for the constant of variation and the equation for the direct variation. And to do that, we're going to be starting with the formula that we're using, which is y is equal to kx, and then the clue that we are given in this graph. We are given a line, so that means we can associate this in the general formula for an equation of a line y is equal to mx plus b, and y equals mx plus b means that m is the slope and b is your y-intercept. So all we need to do is to find the value of m and the value of b, and we'll be able to write the direct variation equation. First, in the line, we are seeing that we have a point right here, and we know that this point is the y-intercept because this point is crossing the y-axis in the given graph. So now that we have the y-intercept, which is equal to 0, all we need to do is to find the slope. And how are we going to find the slope? We're going to find it by using a point that is also given to us in this table. And what is that point? This right here, which is 4 and 6. So that is the ordered pair for this particular point. And by using the 2 points, we'll be able to use the formula for the slope so that we can find the value of our constant k. And the slope is simply given by rise over run. So there are several ways on how to find the slope of our equation. And I'm going to show you or review you on how to find the slope of our function. And we can find it using this symbol, change in y all over change in x. Or we can also use y sub 2 minus y sub 1, x sub 2 minus x sub 1 as the formula for the slope. Or we can also use y sub 1 minus y sub 2 all over x sub 1 minus x sub 2 as the formula for the slope. But you're not going to be able to find it by using y1 minus y2 and x2 minus x1. This one will not give you the formula for the slope because you need to be consistent with your numerator and your denominator so that you can find the correct value of your slope. And in this particular graph, I'm not going to use this formula, but I'm just going to look at the graph and check the number of units it goes up and the number of units it will go to the right, and that will be my slope. So how are we going to do that? We're going to count the number of units it goes up. So we have 1, 2, 3, 4, 5, 6. So this is going to be our rise, 6 units. And our run is the number of units it will go to the right, going to the second point of your graph, which is 4 units. 1, 2, 3, 4. And now we have 6 over 4, and we know that 6 over 4 can still be simplified into 3 all over 2, and that will be our slope, also known as the constant variation in our formula. So remember that in linear equation, m is the slope, and it can also be the constant variation in relationship that we are working on in this particular graph. So that is how we solve this problem. So now we have the constant variation. The direct variation equation is simply replacing k with 3 over 2 into y equal to kx formula, and that is the direct variation equation of this relationship, which is y is equal to 3 over 2 x. So this is how we answer problems involving direct variation in mathematics. So our challenge for the day is for you to write the correct formula or direct variation equation from this particular graph that we are seeing. So comment down below and see who's going to get the equation that we're looking for this particular relationship. And for students who are understanding now the relationship that we are establishing in this lesson, just remember your clues to answer word problems involving variations, Direct variation means if your input is going up, your output is also going up. And when your input is going down, your output is also going down. That is the type of numerical relationship that we are establishing in this particular variation. So this is Dr. E, and see you again next time. Bye!